Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week on Exploration, we discuss the fascinating world of science, as well as its impact on society. And today, we're going to talk about Earth Day. Yes, April 22nd. Write that down on your calendar, is Earth Day. And it's hard to believe. It's hard to believe that the first Earth Day was 47 years ago. That's right, it was 1970 when the first Earth Day was declared, and since then it's become an international event. And some people say, well, maybe not much was accomplished, but take a look at what came out of the citizens' pressure, in part because of Earth Day. The creation of the Environmental Protection Agency, the Clean Air Act, Water Quality Improvement Act, the Endangered Species Act. You name it. The momentum generated in the last several decades to protect the environment, in part, was spurred on because of citizens' pressure, which in turn was the motivating factor behind Earth Day. So, in today's exploration, first of all, we're going to summarize where we are, the state of the Earth. Some people throw up their hands and say, well, perhaps we're going backwards now. Perhaps the Environmental Protection Agency is going to be gutted. Perhaps fuel standards are going to go backwards. Well, we'll say a few things about the state of the Earth in the first half of exploration. And then we'll answer some of the emails that I get. One email that I get is, well, about the future. People are kind of worried about what's in store for us in the future if things keep on going the way they are. What's going to happen? What's going to happen to our cities, especially those cities next to the oceans? What happens to violent swings in the weather? For example, the polar vortex could become unstable. Look at the South Pole. Some people think that the Larsen Ice Shelf Sea is going to break off. A huge chunk of Antarctica could break off the size of the state of Delaware. So we'll say a few things about the future. Well, let's just jump right into the top story, which is Earth Day. Yes, it's hard to believe, but 47 years ago was the first Earth Day. What spurred it on, of course, was a disaster. There was an oil spill. A huge oil spill in Santa Barbara, California, right off the coast of very expensive homes and very nice areas. And these people can vote. These people had access to the media. These people went on television to protest the fact that we were not protecting the oceans, we were not protecting our own coastlines, and as a consequence, we had these disasters with more disasters to come. Well, Senator Gaylord Nelson and others got together and said, well, why not turn this tragedy of 1969 into a celebration of the Earth, to focus political pressure, to create legislation to save the planet? And that was the first Earth Day in 1970. Now, some people looking at progress since then simply throw up their hands and say it was co-opted. I mean, let's face it, everybody and their brother wants to be part of Earth Day. Everyone wants to be green. Even polluters want to be, quote, green in order to sell their products. Well, yeah, it was co-opted to a large degree, but look at what it accomplished. It helped to galvanize citizens' pressure so that real concrete legislation could be enacted. The pressure generated by things like Earth Day essentially led to the creation of the Environmental Protection Agency. And as I mentioned before, the Clean Air Act, Water Quality Improvement Act, Endangered Species Act, any number of national legislations went through Congress, spurred on because of citizens' pressure. And so, yes, there's a lesson there, and that lesson is, yes, things like Earth Day can very easily be co-opted, but you have to look at the much larger historic consequences of citizens' pressure. It was the pressure from below, the pressure from you and me, people marching in the streets, demanding protection for endangered species, demanding safeguards to protect our air and water quality. All of that did amount to something. However, let's be blunt about it. If you take a look at the state of the Earth today, there's a very long list of things to be concerned about. So let's just summarize them really quickly. When you look at the state of the Earth, you have to realize that last year went down as the hottest year ever recorded in the history of science. And for that matter, the last decade went down as the hottest decade ever recorded in the history of science. And if you plot it on graph paper, you see a straight line. Things are not getting cooler, things are getting hotter. And not only can you see this by looking at the average temperature at different sites around the Earth, you can see it by looking at satellites. Satellites very easily can show the fact that the Earth is not cooling down, as some people have said, but it's actually heating up. Now, here is the rub. Even though even the so-called skeptics now grudgingly say that, yes, the Earth is heating up, the question is, what's causing it? What's driving it? Well, some people say these are natural cycles. Therefore, nothing to be worried about. Things that are beyond our control is in Mother Nature's ballpark. Other people are saying, well, yeah, 10,000 years ago, we had the end of the last ice age, and things have been warming up for the last 10,000 years, and that's absolutely true. However, when you take a look at the temperature rise in the last several decades, you realize that there's been a spike. Not just this slow increase in temperature since the end of the last ice age 10,000 years ago. No, we're talking about within the last century, a spike in terms of rising temperature. And that's where scientists say, aha, with 95% confidence, not 100%, but with 95% confidence, we can show that it's human activity that is causing this spike. For example, let's remove human activity using our computer programs. We can do that, of course, because human activity is nothing but one variable in this very complex equation that we put into a computer. When you remove human activity, you find, bingo, the curve is flat. That is, temperatures do rise slowly for the last 10,000 years, but there is no spike at all. And when you add in human activity, bingo, you get exactly the spike that we see in the last 100 years. Now, some people say, is that proof? Is that 100% proof? Well, the answer is no. But we can say that with 95% confidence. With 95% confidence, it is human activity which is causing this sudden rise. Now, if that rise in temperature is correct, we should see the effects of it around the Earth. And that's exactly what we see, starting with the North Pole. When you look at the North Pole, realize that, yes, it's seasonal in terms of the thickness of the ice. But when things get warm in the North Pole in summertime, we see that many months of the year, we see that there's almost a complete melting of the ice there. On average, we can see that the thickness of North Polar ice has been reduced by about 50%. And we see this by analyzing submarine data. It was the famous Nautilus submarine that went underneath the North Polar ice back in the 1950s and measured the thickness of the ice. And when you compare the data from nuclear submarines of 50 years ago with the data today, bingo, we see a 50% decrease in the thickness of the ice. And of course, the thickness of the ice is seasonal, but on average, you see a 50% reduction in that thickness. Now, this in turn, in part, translates to sea level rise. Now, we're not talking about melting of all the ice on the planet Earth. There's a lot of ice out there. No, as the Earth heats up, water expands. We use that same effect when you open up a stuck jar. If you have a jar that's stuck with a metal cap, what do? You put it underneath the hot water in your kitchen sink. The hot water expands the cap, and that allows you to open the cap, even if it's stuck. And the same thing applies to ocean water. And that, by the way, parenthetically, is the reason why when you ride on a train, you hear that click, click, click sound. Ever wonder why we make rails with a small separation between the rails? And when you're train goes over the rails, you hear this click, click, click. Well, the reason is you have to compensate for the fact that in summertime and on a hot day, the rails will expand. That's why the engineers deliberately put a separation between the rails on a railroad track, and that's why you hear that click, click, click. Well, the same thing happens with the expanding water in our oceans. And when you look at the rate at which sea levels rise, there's an exact correlation with temperature. As the temperature of the Earth rises, it means that water expands and sea levels rise. And just remember that the coastline is not flat. It turns out that for every vertical inch of sea level rise, the beaches can lose 100 inches of shoreline. And that's one of the reasons why in many areas we see whole beach areas that have been receded. Now, you may ask yourself a simple question. Why should we care? Why should we care about rising sea level? Well, it turns out that approximately 50% of the population of the United States resides in coastal areas near the East Coast and the West Coast. And as sea levels begin to rise, scientists have redrawn the map. They've redrawn the map of what New York City, Boston, San Francisco, Los Angeles will look like in the coming decades. Go to the internet, and you can see what Florida will look like by 2050, by 2100. And in the future, Florida will just be a stump. And remember that this happened in the past. We scientists can recreate the coastline of North America centuries, thousands, millions of years ago. In fact, during the age of the dinosaurs, it was actually much hotter than it is now. And sea levels were much, much higher during the time of the dinosaurs. And it means that our coastlines were virtually unrecognizable when you start to go backwards in time. And so when you look at our great cities, realize that we're going to have problems as sea levels begin to rise. First of all, if you take a look at Manhattan, Wall Street is in one of the lowest parts of the city. And we may have to have sea dikes and sea levees and sea locks in order to preserve Manhattan from being flooded. Or take a look at Boston. Realize that a map of Boston during the Revolutionary days is completely different from Boston of today because of landfill. And so you begin to realize that, oh my God, many of our American cities are simply not going to survive in their modern state as sea levels begin to rise. Now, the first warnings of this will be massive storms which can loft enormous amounts of water into the land, causing, for example, a shutdown of the subway system. This actually happened in New York City years ago. There was a nor'easter which then created tremendous waves, which then flooded the New York subway system, causing it to be closed. And, of course, we had Hurricane Sandy, which was essentially a wake-up call as to what could happen if nor'easters and the flooding of our subway system becomes a regular feature of the weather landscape. Not to mention the fact that not only do we have a thinning of the ice in the North Pole, we have thinning of the ice in the South Pole as well, causing enormous chunks of ice to break off. Already we see that Larsen Ice Shelf A and B have broken off Antarctica, and the next chunk is Larsen Ice Shelf C, which is the size of the state of Delaware. And over Christmas last year, there was an enormous crack that emerged in the Antarctic, meaning that the Larsen Ice Shelf C will definitely break off. It could happen, in fact, any day, or perhaps in a few weeks, or maximum, perhaps in a few months. But we see this enormous crack that is growing right before our eyes. Satellite photographs which clearly show that, yes, the South Polar region is unstable. Now, why is that important? Well, first of all, it's an ice shelf. It sits on top of the water. So even if the Larsen Ice Shelf completely melted, it would not affect the level of sea level. However, what's behind Larsen Ice Shelf C is the ice sheets. The ice sheets sit on land. And if the Larsen Ice Shelf disintegrates, it means that the ice sheets will slide off the land into the water, thereby raising sea levels. And the amount of ice contained in the South Pole is enormous. If it were to melt completely, and of course we don't expect that to happen anytime soon, but the coastlines of the world would be completely altered. You wouldn't even recognize what the coastlines look like because there's so much ice and water that is held within the South Pole. Now, you don't have to go to the South Pole in order to see the effect of global warming. Take a look at the seasons that even farmers understand. Farmers, of course, have to be astute students of the weather, and they know that summers are on average almost a week longer than before, which means that growing seasons have to be altered, crop rotations have to be altered, the kinds of crops they plant and when they plant all have to be changed because of global warming, because summertime is basically a week longer than normal, and wintertime is about a week shorter than normal. And this will eventually wind up in our supermarket. The cost of crops could change as the seasons begin to change. And just remember that animal cycles, the cycles of animals are going to be changed too. We often say that the early bird catches the worm. But what happens if the worms and the early bird cycles are thrown a-kilter? It means that even animal cycles could be affected. Now, how does that affect you and me? It affects you and me because diseases are also a function of temperature. Some people think that the West Nile virus, which caught a lot of people by surprise on the two coasts, is a byproduct of the fact that mosquitoes are beginning to migrate north. Now, mosquitoes, of course, are notorious carriers of tropical diseases. However, mosquitoes can only go so far north before it gets too cold and the eggs die because of the ice. However, as the North Polar regions begin to melt, it means that tropical diseases can spread north as a consequence. And that's something that we have to worry about, the spread of diseases as well. Now, let's do a little bit of prediction into the future. What could happen? Well, you see, global warming in some sense is a misnomer. We're not talking about the steady rise of the temperature of the Earth. Every time there's a gigantic snowstorm, the naysayers say, ha, the global warming people look like a bunch of stupid idiots because it's snowing outside. Everyone is underneath the snow cover. Where is global warming? Well, you see, global warming is a misnomer because we're not talking about the uniform warming of the Earth. When you inject more energy into the Earth, it sloshes around, which means that we have swings. We have increase in the global swings so that in one area you could have forest fires because the tinder has dried out. In another area you can have flooding because there's massive rainfall. In another area you could have droughts, all at the same time. So it's global swings that we're talking about and not simply a uniform warming of the planet Earth. For example, we had a cold spell just a few weeks ago, and if you take a look at the jet stream that carries cold Arctic air down to the United States has been rather erratic. And why is that? Because of the polar vortex. So what is the polar vortex, and how can Arctic air have any relationship with global warming? Well, here's the link. The polar vortex is basically a hurricane on top of the North Pole. Usually, if the temperatures are quite different between the outside and the inside of this hurricane, the winds travel very quickly, and the polar vortex is quite stable. And if the polar vortex is stable, it means that it does not wander around so much, meaning that the jet stream is not going to be disrupted. However, as the outside and the inside of this polar vortex begin to rise, the temperature difference between the inside and the outside gets smaller and smaller because everything is warming up because of global warming. That means that this hurricane becomes unstable. It begins to wobble. And as the polar vortex begins to wobble, it takes the jet stream with it. And that's one of the reasons why a few years ago we had this tremendous erratic winter storm, and all the naysayers came out and said, ha, we knew it all along. Global warming is a hoax. It's snowing outside like it's never been before. Well, there's a reason for that. And as the North Polar region starts to warm up, the polar vortex becomes unstable, wind velocity decreases, the temperature difference between the inside and the outside narrows, and as the polar vortex becomes more unstable, it means that it wanders, and as it wanders, it affects the jet stream, which in turn can create enormous disruption of our weather. It could take huge quantities of Arctic ice and send them right over North America. Now, some of the critics also say, well, what proof do you have? What happens if you don't trust these computer programs? What proof that you have that carbon dioxide and temperature are related? Well, here's one way you can see the direct relationship between carbon dioxide and weather in a real-life situation. And that is when you look at the planet Mars and the planet Venus. It used to be back in the 1950s that we thought that Venus was a tropical wonderland. Science fiction writers said that our astronauts of the future would basically have resorts and retreat for vacation sites in Venus because Venus is a wonderland of tropical tourist attractions. Wrong. All those predictions were wrong. In fact, Carl Sagan had predicted ahead of time that Venus could be unusually warm because of the carbon dioxide in its atmosphere. The atmosphere of Venus is almost 100% carbon dioxide, which means that greenhouse gases like carbon dioxide can trap sunlight. Sunlight will go right through carbon dioxide, no problem. But when sunlight heats up the ground, it releases heat radiation. Heat radiation is infrared. Infrared cannot penetrate air that well. So it's a one-way street. Light goes right through the atmosphere, warms up Venus, because carbon dioxide is transparent. But when it turns into heat radiation cannot go through carbon dioxide that well. In fact, it's opaque with regards to carbon dioxide. So the energy is trapped. And that's why the surface temperature of Venus is 900 degrees Fahrenheit, hotter than a baker's oven. Lead, tin are molten on the surface of Venus because the temperature of the surface of Venus is hotter than the melting point of lead or tin. If you were to walk on the surface of Venus, you might actually plunge into a whole pool of molten lead or molten tin if you don't watch out. So that's the greenhouse effect gone berserk. So we now know that, yes, the greenhouse effect is not just science fiction. Here we have a real live situation, an entire planet, the greenhouse planet, which is a byproduct of global warming. And then as we go into the future and start to make predictions, some people think that the gutting of the EPA by the Trump administration and by restrictions on fossil fuels being relaxed could cause a tremendous collapse of the environment. Well, yes and no. Of course, the news is bad whenever you gut things like the EPA, but there's so much momentum built up around conservation, solar, and wind that even these setbacks could be temporary. For example, yes, solar prices and wind prices are still not quite competitive with regards to fossil fuel prices. However, what's the bottleneck? The bottleneck preventing us from entering a solar age or a wind age is storage. It's the battery. Batteries are useful when the sun doesn't shine or the winds don't blow, but battery efficiency is not very good. Why? Because if you're an inventor, you realize that the time you spend creating a better battery could be a waste of time. But things have changed. Now there's an enormous pressure to create the super battery, Therefore, prices have dropped 7% per year. This is enormous. There's been a tremendous drop in the cost of batteries because of interest, because we realize that batteries are essential in the computer age and essential in the home as well. In fact, Elon Musk of Tesla Motors has invested billions in the creation of a super battery that can be used when the sun doesn't shine and the winds don't blow. And even utilities are interested in this idea, because utilities have to provide peak summer and peak winter capacity, even when it's not peak summer or peak winter. Now, from a utilities point of view, that's a waste of energy to create a gigantic power plant that can meet peak summer and peak winter demand for energy when it's not peak summer or peak winter. That's why they're interested, because they want to even out the heat cycle. The heat cycle, of course, means that it's warm during the day, it's warm during the summertime, but it's cooler at night, and it's cooler during the winter months. But with a super battery, you can even it out, thereby perhaps ushering in the solar age for real. So, in other words, on one hand, things look bleak. We have an administration which seems to be hell-bent on reversing many of the gains of the last few decades. However, take a look at market forces. Take a look at the advance of technology. There's been a revolution in terms of battery technology and reducing the cost of generating electricity using batteries. And that's been the main bottleneck that has prevented the commercialization of solar and wind. And of course, in Europe, wind power has become a major player with regards to the production of energy. So, in other words, a tremendous amount of momentum has been built up. A lot of it is enshrined in law, and we have many nations, especially in Europe, that are very definitely part of the new energy revolution. And we have many nations in Europe that are definitely part of the energy revolution. So we'll see how things play out. But my only point of view is that it takes more than just one administration to try to roll back the gains of the last several decades. But we'll wait and see. And that's perhaps where you come in the picture. Well, I'm afraid that's it for the first part of Exploration. In the second part of Exploration, we're going to bring on Lori Buongiorno, author of the book Green, Greener, Greenest, to tell us what to do about all the energy problems and the environmental problems we face. So instead of moaning and groaning, why not translate some of our goodwill into action? Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is the second half of Exploration. In the first half of Exploration, we talked about Earth Day. Is it a con? Is it really something of substance? Or did it really leave a historic impact? And most important, what does it mean for the future? So in the first part of Exploration, we talked about the state of the Earth. Well, in the second half of Exploration, we're going to ask another question. What can we do about it? You and me. Of course, we can always put pressure on politicians, but what about our own lifestyles? With us today is Lori Buongiorno, author of the book Green, Greener, Greenest, concerning how you can be part of the Green Revolution. Now, again, not everyone has the time to go out there to the barricades and make a demonstration and pressure for certain kinds of legislation in Congress. However, we all are consumers. And so with us today is Lori Buongiorno, who will talk to us about what you and me as consumers can do on Earth Day to do our tiny, tiny little part to make the Earth a better place. And again, if you really want to make the Earth a better place, perhaps you should become more active politically. However, that's a personal choice. And so once again, with us today is Lori Buongiorno, author of the book Green, Greener, and Greenest. Well, now I'd like to introduce our special guest for today. We're very delighted to have with us Lori Bongiorno. She's a journalist at Business Week for the past 6 years before becoming a freelance writer for The Green Guide, an environmental health newsletter. And she's the author of a new book called Green, Greener, and Greenest, a practical guide to making eco-smart choices as a part of your life. You know, on Exploration, we've had a number of experts talking about the global impact of global warming, talking about the rise of sea levels, talking about energy consumption, oil, energy policy. We've tackled the issue from a number of directions, but Lori Bongiorno takes it to a very, very personal and practical level. What can you do in your lifestyle? What can you do in things that you do every single day of the year to help preserve the environment? Well, that's where the next book comes in, Green, Greener, and Greenest, when we break it down as to what you can do in your lifestyle to save the earth. The first question for you, Lori, is how did you first get interested in environmental issues and science?
Well, I was a business reporter for many years and got interested in health reporting after my husband died after a 2-year battle with melanoma. I also had 2 young children, one of whom had severe and extensive food allergies. So I started to become interested in health, and I felt like preventing major problems was the best way to go. And so I decided to write about health and started writing about health. And subsequently, a friend asked me to write for her environmental health newsletter. And I wasn't interested at first because I didn't really consider myself an environmentalist. But when she explained the connection between health and the environment, I decided to give it a try. And then I got really interested in the connection between personal health and the health of the planet.
Okay, and why write the book, Green, Greener, and Greenest?
I wrote the book because I believe that most people want to make positive changes that benefit the environment, but I found that a lot of people were confused or overwhelmed or didn't know where to start. So I wanted to write the book so that I could show people the whole spectrum of green options out there, because there isn't just one right way to be green. And anything you can do, small or large, is worthwhile. I basically wanted to make it less overwhelming for people.
Okay, well, let's just jump right into some of the topics, because one thing good about your book is that it's very specific and very much related to people's lifestyles. Okay, food and beverages. How do we go from green, greener to greenest? First of all, what is the difference between green, greener, and greenest, and how does that apply to food and beverages?
Okay, well, the difference between green, greener, and greenest is green tips are easy and inexpensive. Greener tips are for those who want to spend or who have the interest, the time, or the budget to go a little bit deeper into an issue. And greenest suggestions are for those who are able to fully take on an issue. And lots of times those greenest suggestions are for someone who, involve getting more active in a broader way.
And I guess the greenest category would also call for political action as well, right?
Exactly. In many cases, it's for broader community action or political action.
Okay, well, let's just jump right into the contents of your book. First of all, what we eat and what we drink. How does this stack up to green, greener, and greenest?
Well, I mean, there's so many different categories of food, but we can do produce because that's something that a lot of people care about. So one thing that people can do if they're worried about, a green thing that you can do if you're worried about pesticide residues, is eat a wide variety of produce to get all the nutrients you need and to protect yourself from exposure to the same pesticides. A greener thing that you can do is to buy organic versions of the most contaminated produce, and some of the environmental working group has a list of the top 12 most contaminated fruits and vegetables and the least contaminated. And some of the most contaminated are things like peaches and apples and strawberries, and some of the least contaminated are things like spinach, pears, and cucumbers.
And
And then greenest, and another thing that you can do that's greener is to buy local whenever possible. Going to your local farmers market cuts down on fuel to ship food across the country, and you're getting tastier and healthier in some cases food than you do at the supermarket. Greenest is to, grow your own produce or join a community-supported agriculture program where you can, at the beginning of the growing season, buy a share of a local farmer's harvest. Pick it up each week.
Okay, and let's be specific. You have a section on fish and seafoods. Everyone wants to get omega-3 fatty acids for their health benefits, but also seafood contains mercury left over from the burning of coal. Coal-fired plants produce an enormous amount of mercury, which then lands back in the oceans as acid rain, which then gets into salmon and whatever, and then gets into your body. So what are your thoughts about fish and seafood?
Well, one of the easiest things you can do is to get a fish list or a fish card and bring it with you next time you go to the fish store or you go to the supermarket. But some tips that I have in here are in green, green, or greenest is green. When eating canned tuna, buy chunk light, not albacore tuna, which has 3 times the amounts of mercury as light tuna. So that's one way to do something that's fairly easy. A greener thing that you can do is choose wild and canned Alaskan salmon over farm-raised salmon. Farm-raised salmon tends to be fattier, and some of their feed, which is where a lot of these toxins like PCBs concentrate, and also the feed is sometimes contaminated with some of those chemicals. A greenest thing that you can do is, this is a place to try and get active. Urge your elected officials to support legislation that's aimed at reducing mercury in the environment so that we can eat all kinds of fish and not have to worry about it.
Okay, and moving on to meat and dairy products. Of course, we're all concerned about animal fat, which tends to clog up our bodies and our arteries. But we also have to worry about antibiotics, and we have to also worry about other things in meat and dairy. Any thoughts?
Yes. I mean, one of the things that you can do that's really easy, and this is a green suggestion in the book, is minimize exposure to fat. This is where many, for obvious reasons, but also because it contains, that's where a lot of the toxic chemicals such as dioxins concentrate. So if you either buy low-fat dairy products or you buy low-fat meat or cut off the fat from the meat when you're cooking it, these are ways that you could cut down on fat and it's healthier. Greener things, in terms of meat would be, to buy organic when possible. It's your best bet that animals weren't raised with antibiotics or added hormones or, many other harmful practices. With dairy and meat and red meat, grass-fed is another thing to look for. It's leaner, so you have to cook it differently, but cows were not meant to be raised on grain. They were meant to be raised on grass, and grass-fed cows' meat and milk is actually healthier for you. It has some beneficial fats that are actually good for you. A greenest thing would be to eliminate meat not dairy. Eliminate meat entirely from your diet. But there are, that's the greenest thing. A green thing would be to eat less meat.
Okay.
So you don't have to go straight to that.
Now, we have this perpetual problem that even though things that are labeled organic may not be organic. I mean, what does it mean if it says organic? Maybe it's a scam. Any thoughts about what it means when a product says organic? I mean, how can you be sure?
Well, it really depends on the product. In food, if it has the USDA certified organic stamp of approval on it, it means that the food, like the fruits or vegetables, it means that there were very strict standards that were met and that a third party verified it. So if you see an organic label with the USDA seal of approval, you can be pretty sure that you're getting an organic product when it comes to food.
And what about the perpetual problem of plastic versus paper wrappers and bags?
That is an age-old question. It really depends. I mean, basically, the answer is to use cloth whenever possible. But if that's not possible, then if you're near a body of water and you can get recycled paper bags, you should choose that. If you are not near a body of water, because you don't want the plastic bags to end up in the ocean and harm wildlife, if you are not near a body of water or the bags are not made from recycled paper, post-consumer recycled paper, then you're better off choosing plastic. But you should also think about what you're actually doing with these bags when you're done with them. I mean, paper can be recycled. Plastic, I use plastic bags. I reuse them as garbage liners, so I don't have to buy garbage liners. So think about what you do with it when you're done with them as well.
And can you be sure that the plastic is biodegradable?
No. I mean, you could be pretty sure that it's not biodegradable and it's going to be in a landfill for a long time. So you don't, that's why you want to try and recycle. I mean, in New York City, you're going to be able to bring plastic bags to stores and get them recycled, or you can reuse them.
Okay. Well, now moving on to the home. Personal care products, babies and children. One problem is diapers. Some people complain that, first of all, diapers are extremely filthy and contain tremendous amount of germs, and we generate enormous quantities of Pampers for anyone who's ever changed a diaper before. What are your thoughts?
Well, I mean, I think a big question that people think about in terms of diapers is whether or not to use reusable or disposable. And one of the things I found in doing this research is that it doesn't really make a huge difference one way or the other. They both take up resources. They both have pros and cons. And the conclusion I came to is that, people should actually think about using diapers and think about, their needs and their lifestyles and do what's best for them. But to also, if you live in a place where landfill is an issue, then maybe, and you can use if you can use reusable, great. But if you're in a place where water quality is an issue, then using disposable is actually better. Something like diapers, I mean, they're a necessity, although there is, one of the greenest suggestions in the book is that there is this new thing called the elimination communication method that is for gaining some momentum in the United States. And the basic gist is that there are certain signals that a baby makes in advance of having to go. And so parents can actually start potty training a baby pretty early on. I mean, that seems to me not something that many people can do, but that's pretty much the only way to really cut down on diaper use.
Okay, and speaking about home care products, the average person goes through an enormous amount of chemicals. You mentioned, for example, in your book, hair dye, nail polish, deodorants, and antiperspirants, sun protection. We go through an enormous amount of chemicals that go right down the drain. What are your thoughts about minimizing our imprint on the environment?
Yes, and on our personal health. I mean, most people use about 9 different personal care products a day, encountering a combined average of 126 different ingredients. One of the easiest things that you can do is to protect your own health and the health of the planet is to use fewer products. That's a green suggestion in the book. That's one thing you can do. I mean, other things that you can do are trying to stay away from the most harmful chemicals.
Like?
Well, one thing that I guess is pretty hard to find, petroleum byproducts. There is a chemical called 1,4-dioxane that has been getting a lot of attention lately because it can be contaminated with carcinogenic impurities. The problem is that it's really hard to know from reading the labels what it's in, and so one thing that I tell people to do is go to the Environmental Working Group's cosmetics database, which is www.cosmeticsdatabase.com, and you could just type in the name of a product or type in the name of a chemical. It's really very user-friendly, and it can help you learn a lot about what you're using on your body. A greenest thing that people could do is, either buy from companies that are starting to make changes, and some of those companies are Aubrey Organics, Jason Natural Products, Burt's Bees, or try to get more active politically.
Okay, and speaking about beverages, a lot of people drink bottled water. First of all, is there any advantage at all to drinking bottled water? And second of all, there are a lot of products that guarantee filtering of water, but are they just bunk, or can they really filter water? Okay.
Well, first things first, there is no proof that bottled water is any better than tap water. In fact, if the NRDC did a study that showed that 25% of bottled water is just tap water, and sometimes it's further treated and sometimes it's not. I mean, experts agree that drinking tap water is the way to go for many reasons. Also, it's very expensive for a lot of people.
Sure.
Now, in terms of water filters, I mean, the best way to know, first of all water the best way to figure out which water filter you need is to find out what's in your water. And everyone gets a drinking water report called the Drinking Water Quality Report in around July 1st of every year. And that can tell you what's in your water, or you can get your water tested. But once you know what's in your water, then you know what you have to get rid of. And there are 3 different kinds of filters: carbon filters, distillers, and reverse osmosis. And they each get rid of different things. The one thing you want to look for in all filters is to make sure it's NSF certified, which is an independent nonprofit that certifies food products and water-related products. So just make sure it's NSF certified, and make sure you change the filter according to manufacturer's directions.
Okay, let me ask you a question that is not addressed in this book, but people have asked me, and that is, if you analyze your blood for chemicals like lead and mercury, of course you can go to a scientific laboratory and find out exactly what kind of junk is inside your blood. But that's not for the average person. How would an average person be able to find out how much lead, mercury, and different kind of pollutants are in their body by analyzing the blood, and can you remove them? Any thoughts?
Wow, that's a good question. Lead, most kids under the age of 6 get lead tests at the doctor's office pretty regularly. And I think, that's fairly easily measured in the blood, and people have access to that. Mercury, the same thing. You can go to your doctor and ask for a blood test. You can also go to the Sierra Club, and Greenpeace right now have a kit that they're selling for, I think it's $25, and you can sniff a piece of your hair off and send it to their lab, and they'll tell you how much mercury you have in your body. It depends on what the chemical is in terms of what you can do about it. In the book, I say continually, prevention is your best bet. A chemical like bisphenol A, which is getting a lot of attention these days because of plastic baby bottles, it has estrogenic properties, and it can leach out of some plastic baby bottles and bottles in general. That doesn't stay in your body for a long time, but we're continually exposed to it. Other things stay in your body for a really long time. There's really nothing you can do once it gets there. So it just depends on what your priorities are and what you're trying to accomplish. But I think the first step, if you really want to know what's going on, is going to your doctor and talking to your doctor.
And any thoughts about chelating? Some people have used that to eliminate certain, let's say, metals in their body. We use it in a chemistry laboratory all the time, but what about how safe it is for humans? Any thoughts?
I haven't really looked into that.
Right. Okay, moving on. Home building and improvement. Of course, in metropolitan areas, very few people build their own house from ground up. However, all of us have to worry about formaldehyde in the walls, mold, and stuff like that. So let's talk about home building. First of all, formaldehyde and other chemicals that build up in the walls. Some people say that if you make a house environmentally friendly so that you seal off the house to conserve heat, you build up formaldehyde as a consequence, and that's not good for you. But what are your thoughts?
Well, that is very true. If all these newer constructions should have a really great ventilation system so that you're getting clean air into your home or apartment continually. So ventilation plays a huge part. And preventing some of these chemicals from getting into your house in the first place is another great thing to do. There are more and more, formaldehyde-free products and low VOC products on the market. And there are a lot of great stores that you can go to learn more about them, and great resources that I can tell you about right now. I would say, building green. Well, that's not quite so. That for consumers, buildinggreen.com is a good resource, although some of the better parts of the site are pretty expensive. But the Green Building Resource Center, that's Global Greens, www.globalgreen.org, has a lot of information for consumers. The U.S. Green Building Council, which many people will have heard of in terms of LEED houses or LEED buildings. There's a lot of that in the news. They now have a consumer page website called greenhomeguide.org, which has a lot of resources. But these days, you can just go to an environmental. You can even go to Home Depot, which has a whole assortment of green products, and ask for low off-gassing products like low VOC paints, which are available from many of the major paint suppliers, and even buy wood that doesn't off-gas. You just have to ask questions like that.
Okay, now let's do the big one, and that is energy and carbon. Everyone's worried about that, and people would like to contribute to an environmental movement to reduce our carbon footprint, as we sometimes say. But as you mentioned in your book, the average U.S. household emits 22,000 pounds of carbon dioxide a year. So it seems as if each house is a gigantic wellspring of greenhouse gases. So what do we do about it?
Well, try to use less energy and when you do replace appliances and other things in your apartment or house, make them as energy efficient as possible. In Green, Greener, Greenest, I talk about some of the easy things that you can do to make a big difference. Installing an energy storage thermostat will save you 500 pounds of carbon dioxide a year. Switching to low-flow shower heads doesn't just save you water, it also saves your energy, about 700 pounds a year. If you were to use 5 compact fluorescent light bulbs in your house, 300 pounds of carbon dioxide a year would be saved from being emitted into the atmosphere. Sealing up leaks around doors, those are all things that people can do. Those are 4 things that people can do that are relatively easy, relatively inexpensive, and will make a pretty big difference.
And let's talk about those light bulbs. How good are the new light bulbs compared to the old light bulbs?
Well, it depends. I mean, it just depends on what your priorities are. And I mean, I have a few of them, and they're fine. And I don't put them all over my house. I picked a few different places where they're I use them in my closets. I use them in some hallways. And as incandescents go out, I am thinking about how to replace them. But they are getting better. One thing that consumers, and Environmental Defense has a great light bulb guide that you can go to on their website, which I don't know offhand. The other thing for consumers to know is buy one that's Energy Star certified, because that's going to make that's a guarantee that the bulb will last for a certain amount of time, that the quality of light will be good, and that when you turn it on, it will come on immediately, and there won't be that lag. People worry about, one of the questions I always get is how to dispose of them. That's tricky. Household hazardous waste is how you're supposed to dispose of them with HHW, but one of the things that you can do is go on to earth911.org and see if there's a drop-off center near you. If you can't find one near you, you should seal them in 2 different Ziploc bags before you throw them out. But I think that it's going to get easier for consumers to dispose of CFLs. I think we're going to start to see some in-store disposal options. I mean, the other day I was in Whole Foods and I saw, they're taking batteries now. I think it's just a matter of time before people can start dropping off their old light bulbs as well.
Okay, well, again, you mentioned that the average U.S. household emits 22,000 pounds of carbon dioxide a year. You mentioned how we can reduce it rather easily by maybe 3,000, but we're still up to 20,000 pounds of carbon dioxide a year. Let me ask the big question. What would it take to go solar in a house and remove yourself from the electric grid totally?
Well, I'm not an expert on solar, but what I think it's sort of out of the reach for many people. There's all kinds of new technologies being worked on, which might make which is said to make the price will be coming down. The other thing you can do that without slapping solar panels on your house is you can, and a lot of people in cities don't really have control over that anyway, is you can switch to a green pricing program, and you can buy renewable energies through your utility or through an alternative utility. And that's like a little bit more money each month, probably. I mean, it depends on where you live. But, that's a way to support renewables without having to break the bank.
Well, I'm afraid that's it for Exploration. Once again, this is Dr. Michio Kaku, and you've been listening to Lori Bongiorno, author of the book Green, Greener, and Greenest. Good day.